Here we'll do another continuous interest problem. The question says that we are still starting with $2,000 as with our previous video, and we are compounding continuously at the same interest rate of 3%. But now we are being asked how many years will it take to reach $2,400 in the account. Let's start from our continuous interest formula. Y equals P times E raised to the RT. Our initial investment is $2,000. That's going to be our P value. The interest rate, R, is 3%. If we change to decimal form, we'll have an R of 0.03. The question asks us how many years will it take. Therefore, we can say that our time will be our unknown. And we're trying to reach $2,400 in the account. That's our new amount, and that will be Y. We'll check off what we know now. We know Y, P, and R, and our unknown will be the years, or T. Once again, we have an unknown in our exponent, and we'll need to use a logarithm. Let's begin by plugging in what we do know. Y is 2,400, P is 2,000, multiplied by E times RT. This will be 0.03 times the unknown T. Before we take a logarithm, let's get the exponential by itself. To accomplish this, we'll divide both sides by the number next to the exponential. That's 2,000. If we take the division on the left, we'll end up with 1.2. On the right, the 2,000 cancels, and we'll end up with e to the 0.03t. Now that I have a base e exponential on the right, I can use a special log called a natural log to remove it. The abbreviation for natural log is ln. Therefore, we're going to write ln on the left and place an open parentheses, and another ln on the right and place another open parentheses. The 1.2 on the left goes into the left parentheses, and the base e exponential, e to the 0.03t, will go into the right parentheses. Now, the reason you can use natural log here is because ln, the natural log, and the base e exponential are inverse functions. This means if you take ln of an e, you can cancel them both out. This means on the left, I now just have ln of 1.2, and on the right, I don't have to write the ln or the e, and all I have left is whatever is inside this exponential, 0.03t. Now I can divide on both sides of my new equation by the number in front of t, that's 0.03. If I take that division, I'll have t is equal to ln of 1.2 divided by 0.03. Here we can go to the calculator and do the arithmetic. If we round 2 decimal places, we get 6.08 years. Therefore, to reach $2,400 in the account, we would have to allow our account to compound for 6.08 years.